second bit of material you have to review for your test. And I just want to remind you that I literally make the test question and then I make corresponding questions to put on these pre-tests. If it's on the test, somewhere on these pre-tests, the concept will come across. Also, what types of review questions you need to be prepared for, and how to do the questions. Performance is a function of preparation. On these pre-tests, every time you get a question and you don't know how to do it, I would just assume it's 5 points off your test grade. So make sure you know how to do these. If you struggle with them, I have Monday nights, 7 to 9 o'clock, I have office hours. It's real hard for me to make office hours on Tuesday through Thursday because I work another job. I can try, possibly, but you can also talk to classmates, or you can send me an email. Sometimes if students send me an email about a specific question, I'll make a short video about that question and I'll post it, okay? In fact, I usually do that. Not sometimes, pretty much all the time. So, with that in mind, let's start going over the questions on pretest 3B. What is the image of the point -3, 2 under a reflection in the origin? Well, we like that phrase, count and repeat. So if I do count and repeat, I'm literally going to go through the origin. So I'm going to go down 2 over 3, down another 2 over 3. And that leads me to the point 3, -2. Okay, next up. Which set may be the lengths of the sides of an isosceles triangle? Well, it can't be the first one because 1 plus 1 is equal to 2. And you have to turn around and make sure that you are actually more than 2. 3 plus 3 is less than 8. That won't work. 5, 12, 13 does make a triangle, but it's a right triangle, not isosceles. For isosceles, 4, 4, and 6, because 4 plus 4 is greater than 6, and 4 and 6 are greater than 4. Okay? So, let's take a look now at number 3. And what you see in number 3 is it gives you a diagram of a circle. And this is where we say technically the product of the parts of a chord is equal to the product of the parts of the other chord when they intersect. But in very untechnical language, we have said this times this equals this times this. In some modicum in between of language, CE times ED is going to equal AE times BE. Okay? So the bottom line is that is how we figure this out. So the pieces of AB are 4 and x, so 4 times x equals the pieces of CD are 5 and 8. So 4x is equal to 5 times 8. Oh, and by the way, how did I know that was 8? Because they gave me the whole length. CD is 13, and 13 minus 5 gives me the 8. So 4x is 40, dividing by 4x is 10. Number 4, as shown in the diagram below, BC is extended through this. The measure of angle A is 70. If it's extended through and that external angle is 115, then that means that the remote interior angle has to be 45, and the angle next to or adjacent to the 115 has to be 65, and it wants to know about the comparison of the side length. So the longest side is always across from the biggest angle. So side BC is the longest side because it's across from the 70. Side AC is the shortest side because it's across from the smallest angle. So if you look, one of the choices, choice 4, has AC being less than another one of the sides. And considering AC is the shortest side, that has to be the choice. Number 5, which quadrilateral has diagonals that are always perpendicular bisectors of each other? Well, anything in the parallelogram family will have diagonals that bisect each other. So trapezoid's out, but it could be choices 1, 2, or 4. Now, which ones are perpendicular? Well, only a square has perpendicular diagonals. In a rectangle, the vertices, the corners are perpendicular, but not the diagonals, and nor are the diagonals of a parallelogram perpendicular. They only bisect each other. Number 6, what's the measure of each angle, interior angle of a regular octagon? So there's a couple of different ways to do it, but one of them is to just say, well, the sum of the interior angles is n minus 2 times 180, where n is the number of sides. So 8 minus 2 is 6. 6 times 180 is 1080. I was kind of pretty sleepy while I was doing this, so you might see some stuff scribbled out. 1080 divided by 8 is 135. Okay, like I'm a little tired now too. Number 7, if the sum of the interior angles of a polygon is 1440, then the polygon must be. So again, n minus 2 times 180 is 1440. Now I distribute the 180, and I set up an equation. 180n minus 360, right, because 2 times 180 is 360, equals 1440. Adding the 360, I get 1800. 180 into 1800 goes nice and easy, 10 times. So that means it has to be a decagon, because a 10-sided figure is a decagon. Next up, number 8, consecutive angles of a parallelogram always add up to 180 degrees. So 2x plus 1 plus the x plus 5 is going to equal 180. Combining like terms, same side, same operation. 2x and 1x make 3x, 1 and 5 make 6. Subtracting 6 from both sides, and I get 3x is 174. Dividing by 3x is 58. Which one is a 270 degree counterclockwise rotation? So counterclockwise means going against the way time goes. So there's 90, there's 180, and there's 270. Choice 3. Number 10, what kind of transformation is this? Well, what we're doing is we're sliding it, and a slide is a translation. It's not a dilation, it doesn't get bigger. It's not a line reflection, we're not flipping over anything. It's not a rotation because we're not spinning anything either. That's the importance of the C and the C prime and that little line that connects them. That line shows that it's being slid. Numbers 11 and 12. Which set of numbers could represent the lengths of the sides of a right triangle? To check a right triangle, just put it in a Pythagorean theorem, and whichever one checks is going to be the solution. Okay? So the one that checks is choice 4. And there's my work showing that it checks. You could also remember the Pythagorean triples, and the most basic ones are 3, 4, 5, 5, 12, 13, and of course any multiples of these. And then the next one is 8, 15, 17. Okay. Quadrilateral ABCD, the diagonals bisect its angles. That's interesting. If they bisect its angles and the diagonals are not congruent, it has to be a rhombus. Because if the diagonals were if it was a square, the diagonals would be congruent. So it has to be a rhombus. Something we mentioned briefly in our PowerPoint presentation that you will see on the test in one way, shape, or form involves parallel lines in a circle. Parallel lines in a circle, as it says in red and then are circled in 1, intersect congruent arcs. Parallel lines intersect congruent arcs. Now, why is this important? It's important because if I had angles that reached out, inscribed angles to those arcs, then if there's two angles that intersect congruent arcs, the angles will end up being congruent. So, parallel chords intercept congruent arcs. Number 14, parallelogram ABCD with diagonals AC and BD. Which statement must be true? Does BE have to equal CE? Absolutely not. BE would equal ED? That would be true. Does AB have to equal BC? No. AB has to equal the side opposite it, so it would equal CD. Angle DAE is congruent to angle CBE. DAE, CBE. No, they're on the same side. They're not alternate interior, but choice 2, angle BAE, it's marked, and angle DCE, it is also marked. They are alternate interior angles of parallel lines because the opposite sides of a parallelogram are parallel, hence the name, parallelogram. Number 15, the measures of the angles of a triangle are in the ratio of 5 to 6 to 7. Determine the measure in degrees of the smallest angle. Well, as soon as we know they're in the ratio, this is like when we did supplementary and complementary. That means 5x plus 6x plus 7x has to add up to 180. Adding them all up, that's 18x's is 180, dividing, and you get x is 10. But the smallest angle is not 10, it's the 5x, or the smallest of 5, 6, and 7. So 5 times 10 is 50. Number 16 is a repeat question, so don't bother doing it. Number 17, oh, my favorite song. Little is to big, as little is to big. Little is to big, as little is to big. Oh yeah, rockin' tune there. I fill in the information. CD is 4, CA is 10. CE is x plus 2, and then EB is 4x minus 7. But when I said little is to big, that's all about this little triangle, CDE, and the big triangle, CAB. EB is not a side in the big triangle. CB is a side. So I have to add CE and EB. 1x and 4x make 5x, and 2 and negative 7 make negative 5. So then I can go little is to big as little is to big. 4 is to 10 as the little side, x plus 2 is to the whole big side, 5x minus 5. I cross multiply, I distribute, I get all my x's on one side, all my numbers on the other side. 10x is 40, dividing by 10, x is 4. Nice question there. Nice question for you to know how to do. Number 18, in the diagram below, line L is parallel to M. Line W is a transversal. So what you can tell is that 2 and 3, angles 2 and 3, they're supplementary because they make a straight line and they're adjacent to each other. So add them up. It says underneath angle 2 is 3x plus 17 and angle 3 is 5x minus 21. So I add them up, set them equal to 180. And that gives me 5x's and 3x's make 8x's. 17 and negative 21 is negative 4. Is 180, add 4 to both sides. 8x is 84. Dividing by 8, x is 23. But, oh, what are they asking for? They definitely don't look for x. What they're looking for is the measure of angle 1. But angle 1 is congruent to angle 2. So I have to plug in the 23 into angle 2. And that's 3 times 23 plus 17, and that works out to 86. Okay, number 19. The sides of a triangle measure 7, 4, and 9. The longest side of a similar triangle measures 36. So can you see that the 9, because it's the longest side of 7, 4, and 9, corresponds to the 36, because they're both longest sides? So to get to the 36, I had to multiply the 9 by 4. So then I have to take the shortest side, 4, and multiply that by 4. And that's how I come up with 16. Number 20. Diagram below. 2 parallel lines. You're told that angle HFG is 130. That's the angle out here. You're told that this angle up here is 70. That automatically means that the angle here, the interior angle at E, angle HEF, is going to be 60, because the measure of an exterior angle, like 130, is equal to the sum of the 2 remote interior angles. So if one of them's 70, the other guy has to be 60. And then by alternate interior angles, angle ABE is going to be congruent to angle GEB. So that is 60 degrees. Number 21. Draw the parallelogram JKLM. Angle L exceeds angle M by 30 degrees. The importance of drawing that diagram, remember, you can start your J anywhere, but once you pick a direction, and you can go in either direction, you just have to continue. So I went up and then to the right. So JKLM. What I notice is that L and M are consecutive angles, which means they have to add up to 180. So if L exceeds M by 30, I'll let M be X, and L will be 30 more than that. So that's 2x plus 30 is 180, because that's same side, same operation. Minusing the 30, 2x is 150, and x is 75. Then the other missing angle is 105, angle L. If you were not comfortable with that algebraic approach, you can do trial and error until you get numbers that are 30 apart and add up to 180. So you could try like 50 and 80 and say, oh, well, that's only adds up to 130. Let me try 60 and 90. Well, that only adds up to 150. And you keep going until you get to 180. Number 22. In quadrilateral ABCD, each diagonal bisects the opposite angles. The measure of angle DAB is 70. Then ABCD must be, well, since you bisect the opposite angles, it has to be a rhombus or a square. But since the measure of angle DAB is 70, that's not a right angle. And a square would have a right angle at A, so it has to just be a rhombus. All right, I'm going to pick up on number 23 on the next video.